So I'll share my screen. So you can stop your capture by clicking the red button at the top of your screen. Sure. Okay. So let me know if you can see my screen.
Yes, I can see.
All right. So, Rose, are you there?
I'm here.
All right. All right. So I will start by loading the last capture, the last, uh, the last packet that I captured in the last class. So it's already here. You can see it's the first one here. So I'll just click on it. I'll double click on it. Then it will load it for me. It is somewhere join. Okay, so this is the whole packet. So if you want to load yours, this same packet, if you want to load, you can just go to file. When you download it, go to open and then go to the folder where the download is saved. Right. So when you go there, select the file, it will load it like this. So what I was explaining last time, I think I stopped with ICMP. We were able to capture some packets sent through ping request and trace that. And then I explained um, how the reason why we are saying UDP protocol, right? So it's because we were on call that day. So and we said that live streaming voice over calls are usually sent over UDP protocol, right? So and then I explained that this part. So the reason why we are seeing this. Okay, so let me filter first. Let me filter with ICMP. So I said if you write run filter command here, it will show red. Like if I type ICM now, so it means it does not recognize anything like ICM. So ICMP that it recognizes it will show red. And then if I filter by this, so it will show only packets and the ICMP protocol. It is the thing that it the other time. So my IP address that day was this, and then we pinged Facebook. IP address of Facebook was this, right? So and then I explained that the our ping we send a request and then Facebook will reply, and that's what we are seeing here. My first ping here was this, as you can see, it's tagged as request. Then Facebook replies the ping, as you can see, it's tagged as reply. So the communication will go like that the packets until the packet is sent completely. So this last one is showing where is majorly about this. So let's see. This one is no response. Yeah. So now I wanted to explain the ICMP, the categorization of the OSI model TCP IP model via with all these categorization bring internet protocol and the ICMP protocol, what is inside it, right? So if we check other packets that are not ICMP, that are not through ICMP protocol, you might not see this ICMP protocol here. You see um, another thing. Within visited websites, we would have do maybe HTTP, no HTTP protocol. So I don't think we visited any website that day through any browser. It would have been captured here. And then if you filter with HTTP, you will see all the ones that are HTTP protocol. So majorly that the last class was just to introduce us to the use of wireshark, right? So we will explore it later, capture more packets using more protocol like HTTP, and then we explore what's inside HTTP request and all that. So yeah, so basically that is that is so that's what we have here. So the interpretation of the ICMP using the TCP/IP model, how many layers is does TCP/IP model work with? How many layers? Hmm? Hello.
We can hear you.
Yeah, I'm asking a question. How many layers does
What did you
TCP/IP
say?
work with? How many layers does TCP/IP
Hmm.
protocol works with? How many layers did we look at that day?
Three.
Yeah, mention one.
Huh?
Mention one of them.
Hmm. Okay, can you mention one? I'll mention the others.
Application layer.
Huh?
Application layer.
Hello?
Application layer.
Oh God.
Can you?
Application layer.
Yes, yes.
Yes, I can hear you.
Yes, application layer. That's what I said.
I can't remember anyone.
So it's actually four layers, actually, not three. There are four layers. So okay, we cleared it. So let me go back to okay, and then we mentioned something about TCP TCP layer, right? The transmission layer where hello, can you hear me?
Yes, I can hear you.
Yes, I can hear you.
Okay. So I said that day we mentioned something about transmission layer, which is the layer where communication is established between you and your destination, that is the source and destination server, right? So I'll show you here. Let me see. So so you are going to see where you see arc sync. Where is it? So I said in that layer, three-way handshake happens there, where you see arc, sync, and arc, right? So arc meaning that I explained that part with an example of you meeting someone, right? And then so the arc means that you are extending like handshake to that person, right? And then the person responds back by also extending his or her hands. That's the person is synchronizing with your handshake. And then when that is established, then I will send an acknowledgement message, right? Maybe saying how are you, how is family, and all that, exchanging pleasantries. So that's just that's what the transmission layer does. So as you can see, you see arc, then they will exchange sequence number. So let me see if there will be, there should be sync somewhere. Here you can see SYN, that's sync, and then you see arc again. So let me see. Okay, I don't know what IP this one belongs to, but what is obvious here is that um so there is a communication that has happened here. So it usually happen um when a computer first send a request to another computer, right, over a network. So they establish the async hack, and then communication begins. So you can see that here you can see client hello, what is it saying? So You can see client hello, server also said hello, right? So they are communicating, right? Sending um sending pleasantry and all that. So the way humans communicate, computer also communicates, just in kind of different language, right? Um, so you can see here that this part now does not contain ICMP, right? Because the protocol here is not ICMP protocol, it's TCP. So all you see is TCP and TLS. So you not see ICMP there. So this part is not constant, especially these two, right? It's not constant. So it depends on the number of application.
Can you please increase the size of what you're displaying? It's so tiny. I'm straining my eyes.
The size, this is my full screen. I'm displaying my full screen. This
Okay.
is your network.
It's showing so small.
Are you viewing it on your phone? If you are viewing on your phone, it will be small.
I'm using a
Me, I'm not
laptop.
even seeing your phone at all. Oh.
It's very tiny. It's by the side.
Are you seeing my wireshark screen?
I'm seeing your Wireshark screen, but it's
Okay,
tiny.
but
It's like it's
okay.
only half. It's half on my screen. Yes, it's half on my screen. Then our pictures are on the other side of the screen.
Oh no, it's not supposed to be like that. Okay, I guess because
Rose,
Yeah.
try zooming your phone or whatever you're using to. You can zoom yours to like sit. I think that's the best because if not, if except you want to like display the screen fully on your own. But for me to see it now, I have to zoom mine.
Mm.
let me see if I can match. I think it's because so you are seeing it through Google Meet. That's why. Uh,
Okay. Let's continue. I'll see a way I can zoom it.
yeah, you can try and zoom it like she recommended, but all this
Okay.
can just merge this thing together. Can manage. I can't manage it, but you're supposed to see my desktop screen itself, not on Google Meet. Not Google Meet. Okay, but it's clear here. What I'm seeing here is clear.
Let's continue. Let's continue, please.
Okay.
It's okay.
Yeah, you can try and zoom it. Yeah.
It's fine. Let's continue.
Can you see it? I've tried to zoom some.
It's bigger now.
Okay. I just tried to zoom it. Okay.
It's better now.
All right. Okay. So where was I?
We're talking about the ones down. Because the protocol is okay.
TCP. Okay. Okay. Okay.
They are
So
not UDP.
yes, it's TCP. So if we explore some of these things, so these are the I don't know if let me check some of these IP address 104.183.6.252. So let me check if I will IP lookup. See 104, 1836 to 1836 to 52. Cloud. Okay. So I guess this is one of um, it's one of the service provider that's probably Facebook or Glo is using. 216582137 4. Let's see this one. 2165821 abi 582137 2374. Let me see. Okay, 15 minutes to go. So which one is Facebook? I think I need to do, let me do ping again. Ping Facebook. 102. So let me say IP address equals to 102. What's the IP address again? 102.132.101.35. 102.132.101.35. So I want to filter my communication with facebook.com. Yeah, so this is it. I think we only did ping that day. I think we only did ping that day. And we did trace sats too. Yeah, we need trace sats. Okay, so that's just what we have today. I think we should just go to IP addressing and subnet, IP address and subnet, so that we can also understand all these numbers that we are seeing, understand it better. So any question from here before we go to IP addressing? So like I said, we'll still visit wireshark again, do some more captures using other protocol. So any question from here?
The other stages, you not mention them all.
Which other?
You mentioned two, application and communication. What are the remaining two?
Which one? Which one are you talking about?
We were talking about stages. Asked us stages of what before?
TCP/IP.
Stages of packets. Yes, we're talking about packets, stages.
No,
You mentioned, you asked us to mention,
Zabi.
and then is it layers or be stages?
It's layers now. TCP/IP layers.
Okay, okay,
Eh,
okay. All right. So you said communication and application. What are the other two?
no, I didn't say communication. I say application layer.
And what?
And then I said TCP layer, transmission layer. I don't know.
Application layer and transmission layer.
Mhm.
Eh?
Application layer, transmission layer, then internet internet protocol layer. That's the IP layer, the internet protocol layer. What was the last one?
Frame.
Complete.
The one,
The transporter, the transport layer, internet layer, and the access network access layer.
yes, network layer. Then before the last one is nice. Internet protocol layer, the IP layer. If you read your notes, you will definitely see it there.
I didn't see. That's why I was asking you that day. Where is it? Which
Uh-huh.
date is it?
Oh, okay. Let me show you.
But you say it's on Saturday now,
No,
the
no,
6th.
no. I said wireshark. You were asking about the practicals of wireshark that is not on the note, and I said that wireshark is Saturday. Anything practical is Saturday on the note. So the TCP that I said is week two. This is the TCP/IP. Can you see my screen?
Yes.
uh So TCP/IP, this is day one. Then OSI modem, day two. So that's it. So if you go to this TCP, you see all the layers there. Four layers: application layer, then transport layer. That's TCP, UDP protocol. The internet layer, then the network layer. So those are the four. So anything practical is Saturday, that day six, and that's where you see the Wireshark for this week too. So day three for week two is IP address. So I hope we'll be able to finish it, sha. If we can't finish it, then um we'll carry it over to next week. So I expect that you read ports and networking, network diagram interpretation. We'll carry this one to over. I'll explain it next week, but ensure that you read it so that you familiarize yourself with some of the terms. So I'll probably add an image to this part, this network diagram. There should be a network diagram image there. So IP address. Any other question before you move on? Before we move on.
No.
Okay. So IP address. So IP addressing and subnetting basic. So what is IP address? The full meaning of IP address is internet protocol, and they are usually numbers, numeric numbers assigned to every device on a network so that they can communicate with other device, either on the same network or outside the network, depending on the connection. Right. So example of IP address that we are talking about is this one 192.168.204.243. Right. And then I explain how you can get your own IP address on your computer by using the IP config command in your prompt. Right. So on your Windows, if you open your command prompt and do IP config, you see your IP address there. So yeah, so that's that. So what allow us to be able to browse the internet is the IP address that is assigned to our computer through our ISP. So without that IP address, there's no way you can, because your communication routes through your ISP to wherever your request is going, right? I showed it last week, right? Did I show this last week or not? Rose.
Yes.
I said, did I show it last week?
Did you show what? Your source and destination?
I said your every request that we make usually go through
Mm,
our ISP to the destination where you are requesting for something. So and that's the
mm,
trace sat we did last week. Do you remember?
I know we did tracer last week.
Yeah. So I was able to show that I was able to show the IP address of my ISP, right?
Mm,
So it's true that IP address, my own IP address that is assigned to me, that my communication is able to route to my ISP. And then from my ISP, it will go to um, wherever I want it to go to. Like if I want to visit facebook.com, it will not just go to facebook.com. It will not go directly to Facebook server. Like if I do trace at facebook.com, so it will go through some number of computers within the network, from me to my ISP, from my ISP to another major ISP, bigger ISP, and then to Facebook server, maybe to Facebook data center and all that. So now this is my IP address here, and then this probably belongs to my ISP, right? And then here it has gotten into Facebook infrastructure here. So it's through my IP address that I'm able to perform this communication. So without my IP address, I can't communicate. And even if it's a local network that you don't even have internet, you still have to configure IP address. So that's the function of IP address. So num two functions that IP address actually perform is: number one, it helps us to identify the network, and then it helps us to identify the host. Now, so from this screen, right? So from this screen now, the first three, these first three, it can be first three, it can be first two, and it can be the first one here. But the major thing is that part of this IP address help me identify the network, and part of this IP address help me identify the hosts. Okay, our class is, let me quickly create another one. Does she know that? Does she know that we are here? Okay, she's here. All right. So as I was explaining, so I said one of the functions of IP address is to help us identify the host, and it also helps us identify the the network and the host, right? So yeah, so we have two versions of IP address, the internet protocol. So we have version 4 and we have version 6. So everything you are seeing here is version 4, right? So it's only number with four.
You are no more sharing your screen. No, you're no
Oh, okay.
more sharing your screen.
Let me share. So everything you are seeing on your wireshark is the one that are obvious here is IPv4. IPv4. Now, if you come to this Ethernet 2, so you see source, you see destination. So this is an example of IPv6. It's usually alphanumeric. So let's concentrate.
Hello?
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 Hello, I can hear you. Who's saying hello? Is it better?
I stopped hearing you. It's me. I stopped.
Oh, okay. Okay. Can you hear me now?
Yes. You were saying yes, I can hear now. You were saying version 4 and version 6.
Okay, IPv4 and IPv6. So I said the the IPs you are seeing on your Wireshark screen, source and destination here, the top part is they are all IPv4, IP version 4. So usually numbers like this, they're marketed with dots. So, but if you come to here, if you select one of these and come to this Ethernet 2, so you can see source and destination as well. So this one is IPv6. So it's usually alphanumeric, alphabets and combination of a number. Then instead of dots that is in IP4, is this one is usually column, and then the number of bits is also different. So that's that. Um, okay. So um okay, so the format of the IP address. So it's usually 32 bits. The size is usually 32 bits. I have explained the format, usually in dots. So the maximum number that it can, so it's usually in 32 bits, right? And each 32 bits, I mean, sorry, the total is 32 bits, but each part of it is 8 bits. So like you are seeing on this screen now, you have 192.168.1.1. So each of these represents 8 bits. 192 is 8 bits, 164, 168 is 8 bits, 1 and 1 is also 8 bits. Hello, can you hear me? Hello, can you hear me? Hello. So, hello. I don't know if you can hear me. Okay, my network.
Hello.
Yeah, hello, I can hear you. Can you hear me? Hello?
Yes,
Okay. Yes.
I can hear you.
Alright, so I was explaining, apologies. I was explaining the format of the IP address. So, so I said the total of this is carrying 32 bits, right? So each part of this IP address is carrying 8 bits. So and you can see that it's in 4 places. So which means that 8 bits in 4 places is 32 bits, right? So So the 8 bit is called octet. Octet, right? So the number ranges from 0 to 255. From 0 to 255. So as you can see here, that okay, so you can see this IP address now is starting from 20.189.173.116, right? You can see another one here. It's starting from 2.222, 2.22.249.661. So the number ranges from 0 to 255. You can see this one too, 142 is starting from 142. So each of this number can start from 0 to 255, right? Each octet can start from 0 to 255. Bethel,
Sir?
so do you understand this
So
part?
do you understand this part? Yes, sir.
Okay. So you can explain what octet means now, right? Rose, do you understand?
I don't understand though. It was breaking, so I wasn't hearing completely.
No. Okay, so I said, do you did you hear this part of the format? The format of IP address. So I said,
Me, what I heard is each of those numbers is from 0 to 255.
okay, 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 okay. Yeah, that was the last thing I explained actually. So I was just referencing the examples from wireshark here. That if you can you see this one, this IP address is this one is time so that you not mix it up. Eh. So this is the IP address here. So you can see this one start from 2, this one start from 20, this one start from 142, and then this one it follows 22 follows it. This one with that starts with 20, 189 follows it. So the numbers can range from 0 to 255. That's the that's the format. That was what I explained. Yeah. So each octet, this one is an 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 octet. So each octet can have a range of 0 to 255. It's a single number, right? So 0 to 255, single number, yeah, but can have 3 digits. Single number but can have 3 digits, right? So that's that about that. So I mentioned that one of the function of IP address is to help us recognize the network, it help us recognize the network part and then the host part, right? Now, so the network portion and the host portion. So the network portion identifies the network the device belongs to. So all devices on the same network segment share the same network portion. So let's try and see. Okay, so now this is my IP address here. Wait, let me see if you see some option. Okay. All right. So Now, from the trace sat we did the other time, so it is this one, you can see that they have almost like the same number, 10238, right? They start with 10 to 38. This one also start with 10 to 38. So this computer signifies, these two computer signifies that they are on the same network, right? So now we can say that the network portion of this two IP address is 10.238. The network portion is 10.238. Now the host portion is 19.161. So it's just and it could be that these two are on different network, different subnets, but the same network, different subnets. When we get the subnetting, you understand better, right? So the one that is more clearer, let me see, 129.168.145.70. Okay, it's different this time. I wanted to check compare my IP address for last class and today. So now you can see that this one is also obvious that now, to buttress what I was explaining for this IP address of 10 dots, this address of 10 dots, right? Do you understand? Can you hear me?
Sir,
Okay,
so I'm
Okay,
listening.
okay.
all right. So to buttress what I was saying, this is my IP address today. This is my IP address today. I have 192.168.145.70 today. But when we captured this packet, this was my IP address 192.168.204.243. So what does this indicate now? So it indicates that 192.168 is a network um identifier, while 204.243 is the host identifier here. Because so the network identifier will not change, it's the host identifier that will change. So that's that about network portion and host portion. So host portion identifies the specific device within that network. So now it shows that 192.168.0.0 is the network address, right? And then it signifies that any computer that belongs to that network or that subnet will have 192.168 dot something dot something. So that last two octets will signify the host, the first two octets will signify the network for this configuration, for what I'm seeing here. So it can vary. Like I said, it can only the first one can signify the network, right? Only the first octet sometimes can signify the network, while others will change, right? So
So in this case, how do you now know whether it is only the first one or the first and second that signify the network?
okay, so what I explained is that now, last class, this was my IP address, right? today this is my IP address. So like I said, the network part will not change, the host part will change, the host portion will always change. So from what you can observe here, if you can observe, you see that 192.168 is here for my IP address today. Last class 192.168 is here for my IP address. The only one that changed is the last two octets, the last two octets here, right? So and you see that it's different from the last two octets here. So that's how you identify the network portion and the host portion. So the network portion is 192.168, the host portion is 204.243. So it means that this network is a big network, right? For it to have two octets as the IP, as the host network, and you definitely agree that so many people are connecting to have Glo network now, so it's a big network. So the way you know it's a big network is that, I said each octet has two has what, each octet can range from 0 to 255.
0 to 255.
So which means that you can have 192.168. Okay, let me use today's IP address. So which means that you can have 192.168 dot 145.70, right? You can also have 192.168.146.70. So only this one can change for different people. So it means that only this one, if we want to variate it, it can go from 1 to 255. Only this one alone can go from 1 to 255. Only changing this one alone can also go from 1 to 255, right? um So if you have the two together, let me see if I still remember the math. If we have 255 times 254, that's like 64,000 combinations that we can have, right, for only these two changing, right? So and then you notice that you are seeing something like time to live. I don't know if it's here. It's not here, but it's on that ICMP. I know it's on that. So each IP address have a time to live, so that it's DHCP. It can be assigned to another person. So the time to live is usually in seconds, maybe 1 day or 2 days, right? So I'm sure it will be 1 day here, for so that it can be reassigned to another. So this IP address might have been reassigned to another person using Glo, right? And then tomorrow, the IP address I have today can be reassigned to another person, and then I'll have another IP address. Maybe that one was also um retracted from another person that his or her time to live has expired. So each IP address has a time to live. That's the number of hours or number of seconds the IP address will be assigned to a computer. So that seconds is can be a day or two, right? So once that time expires, it will the DHCP server will reassign another IP address to me, and then it will free that IP address so that it can be assigned to another person. So that's how they will rotate the IP address so that it will not be, it won't get exhausted. It will not, because if they don't rotate it like that, it means that one day I will not be able to browse the internet because there will not be IP address available to be assigned to me. So do you understand the network portion and host portion?
Yes, sir.
Right, good. And then so we have subnet mask. So now subnet mask is also usually 32 bits. Distinguish the network portion from the host portion of an IP address. It uses a series of ones and zeros, right? Ones for network portion and zeros for the host portion. So example of that one is we have 255.255.255.0 or slash 24 in CIDR notation. So let me see how I can show this one better. Mm, okay, so let me see if I can quickly identify. Excuse me. Navigate to network. So it usually shows the available. It readily shows the host portion and the network portion. So like you were asking me the other time that how would you recognize which one is host portion, which one is network portion. So if you see a subnet,
No, that was not what I asked though. I know how to differentiate. You said the first two are network one, and then the last two are for the host.
no, yes,
That's always the
for
case,
the
right?
case, no, it's not always the case. For the case that we just checked, for this
Mm.
case, it's not always the case.
Mm.
Yes, the first, like I explained, only this first octet can identify the network host, while others will just keep changing. Right.
That's the question I asked. The question I asked was, since it is not the same, it's not constant, that once you see the first two, it is network, and then the last two are hosts. What about the numbers will make you know that this has changed, or this should be host and this should be network? What
So,
exactly?
yeah, so that was why I compared my last IP address and this current IP address. Right. So that's where I was able to identify which one is changing and which one is constant. Do you understand?
So you're trying to say anyone that remains constant is
It's the
network.
network. Yes, yes. And then the
Okay.
one that you observe that is changing is the host.
Is the host.
Yes. So and then with this subnet now, you can easily identify which one is subnet, which one is portion and which one is host portion. So because here it says that what the network portion is identified by ones and the the yeah, the network portion is identified by ones and the host portion is identified by zeros. So example is this. we have 255.255.255.0. So all these 255 are ones, right? This one that is showing zero. So all these 255 now is for the network portion. This zero is for the host portion. So which means that now, let me see. So which means that any IP address that has a subnet of 255.255.255.0, it means that only this last one, this last octet will be changing because it has dot zero. It's that zero part that will be changing. Do you understand? So how do we, so these 255 now, they are the parts that are represented by ones. This one is represented by zeros. So if you change this 255 to binary, I don't know, if you go back to your second, no, you don't do binary in secondary school. You go back to your early 100 level days. I don't know if you did maths. So if you convert this one, this denary number to binary, you will get 111 eight in 8 places. Okay, so you get 111 in 8 places. I don't know how we can actually, I don't know how we can demonstrate that. Let's see, it's part of what we are learning. Let me see how we can demonstrate. Let me open notepad. So you are familiar with, is it LCM or HCM? HCM. LCM, yeah, it's LCM. Do you still remember LCM? Or should we skip this part? Yeah, so maybe
What
better.
is LCM?
Lowest common multiple.
Hello?
Hello, hello. Yeah, I can hear you. I'm answering you.
I didn't hear you your voice. You said lowest common what?
Lowest common multiple that you did in primary school.
Lowest common multiple.
Mm. So what we want to do is convert 255 to ones. So we are going to convert it to binary because it's in decimal now. It's in base 10. We convert it to binary. We do is small math here. So if you divide 255 by, so we'll have the remainder on this side of R. So if you divide 255 by 2, help me divide 255 by 2. What are we going to have? Help me divide though, we are doing it together.
So 127.5.
So that point 5 is 1, remainder 1.
Got it.
Do you understand? That point 5 is
Okay, sir.
remainder 1 there. So we have 127, right? Yeah.
Yes, sir.
Yeah, we do another one. 127 divided by 2. What do we have? I think we should have 63 there.
63.5.
5.
That's remainder one.
Remainder 1, we'll put the 1 here. Then 2. 263. So 263 divided by 1, we have what?
63 divided by 1. The size still 263.
No, 63 divided by 2.
131.5.
131. One. No, it can't be 131 now.
Yes, two.
63 divided by 2, not 263.
Oh, sorry.
Yes.
63 divided by 2. Yeah.
Eh,
31.5.
31 remainder 1, Abby.
Yes, sir.
And then we have 31 divided by 2. That's 15 remainder 1.
15.1. Yes, sir.
Yeah. Do you understand? Rose, do you understand? Then this one, 15 divided by 2 will give us 7 remainder
Mm.
1. Abby?
1. Yes, sir.
Rose, do you understand? And then 7 divided by 2 will give us what? 3,
3.5. 3.1.
no, 3.5 now.
Yes, that's remainder 1.
Eh. So 3 divided by 2 will give you what?
It's 0. 0 remainder 1.
It's not 0. It's 1 now. 1,
Sorry, 1 remainder.
1. 1 remain. And then 1 divided by 2. So what's 1 divided by 2?
1 divided by
Zero
2.
point 0.5.
So that is 0. So
Zero point 0.5.
the first part of the decimal is the whole number. Then the other part is the remainder. So it's 0, Abi. Then
Yes,
point
sir.
5, that point 5 is 1. Is
1 remainder 1.
yes. So remainder 1, right? So you can see that everything give us 1. So if you count this number of ones now, you see that it's 8. 1, let's count. 1, 2, 3,
2,
4, 5,
2,
6, 7,
5,
8.
6,
7, 8.
7, 8.
Wait, 1, 2, 3, 4, 5, 6, 7, 8.
So it's 9. Oh.
It's not supposed to be. Okay, sorry. This one is not there. This one is not supposed to be. This is where we started from.
Yes.
This is where, so we are starting from here. This result give us this remainder 1. Eh, so the first one must be there. So you have
The
2,
first one, the 225.
yes. The remainder is not
Yes.
supposed to be there. So we have now
4.
8 now, Abi. So that's what we mean by 8.
Because that's the number that started it.
Yes. So that's what we
Yes.
mean by 8 bit here. It's the number of
Okay.
ones. That's what we mean by 8 bit here. Do you understand? Eh. So this,
Yes, sir.
yes. So this 8 bit, if you have sorry, let me just write it here. So if you have 11111, let me count it. 1, 2, 3, 4, 5, 6, 7, 8. You have 8 there. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. So the total of this one will give you 32. That's what we mean by 32 bits here. Do you understand? Eh,
Yes.
yeah, so that's if we are um So this part, so that's what these 255.255.255, if you express them in their ones, that's what we mean by the 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 ones of the network portion. So it uses a series of ones for the network portion and zeros for the host portion. So all this one
Okay.
is 255, 255, 255. So what it means here is that this one is zero and the other ones are one. So which means that this portion, this part is your network portion and this part is your host portion. You understand? So that's the interpretation. Is it clear now? So this slash 24 now is telling us the number of ones that we have, in, let me, I wanted to show something the other time. Network. Let me see if I can quickly navigate to that part. I think it's the, is it network adapter? It's not network adapter. Let me check here. Let me see. It's not this part. The DHCP. Let me see if I can't remember how to get to that part. Let me see. Not this one. Uh, it's not this part. I wanted to show you how. Let's continue. Probably I will figure it out later. So this slash 24 shows the number of ones that you have in the subnet. Now, so if you have something like this, let's say 255.255.255.0/24 means that you have 24 ones in this format and others are zero. Do you understand me? 24 ones in this format and others are zero. So which means that, okay, so for example now, yes, exactly. So this one, the number of ones you have here is 24. This is 8 in 3 places.
Right.
24. Yeah. Yeah. And
Yes,
you
sir.
have 0 at the end, which means that, so this is, so you can see
Mhm.
something like this. So this is called CIDR notation. We call it CIDR notation. CIDR, CIDR notation. So it's one of it that you get to it. If not today, you can read up, you can read it up, and then we explain better next week. So okay, so that's that part. So you can see here that /24 in CIDR notation, CIDR notation means the first three octets are the network ID and the last octet is for the host. So if you are saying octet, you should know what it means now, right? So IP
Yes.
address classes. So we have, I think, four classes or five. Okay, five classes of IP address here. So only three are usually only class A, B, and C are the common ones that are used. So okay. So we have class A, which is it belongs to a large network. So class A belongs to a large network. As you can see, it can occupy, it can contain many hosts. You can see from it can go from range of 1.00.0.0 to 126.255.255.255. So you can see that here, you can see that this one now, this one is the
Post.
host. Yeah, it identifies the host. Why this one identifies the network address, right? And
Better.
so, and the default subnet mask is this 255.0.0.0. So if you see /8, what does it mean?
Octet.
uh /8, the CIDR
Decider notation. Yes.
notation. It means that is the it
Eight.
means the number
One.
of ones that you
Level
have.
4.
You say? So no, it means that the number of ones that you have,
One in 2555 is that 8.
the number of ones that you have in the network, in the subnet is eight, only eight. So which means that only the first octet is identifying the network host. I mean the network portion, while others are zero, identifying the
Okay.
host portion. So and then we have class B, medium network, which is from 128 to 128.0.0.0 to 191.
Sorry, what do you say is the meaning of that sign in bracket?
Is
The 0 point, the
cider
0 to
notation.
cider notation.
Yeah. So what this one means is that this number means that it identifies the number of ones in the subnet.
What is
Number of figure one. We converted
When
255
you use
to
binary from
we
255.
converted 255 to
okay?
binary the other time. So this one now means that it has 24 ones here. 20, this number of ones here
Okay.
is 24 slash 24,
Okay.
right? So if you now have /8,
Okay.
it means
Okay.
that you have just this first octet
One. Okay.
available for the network portion, while the other ones are for the host.
Host.
Mm. So you can see that it is very large when you have three octets to be filled. 255 times 255 times 255 times 254. So you can imagine the number that you get. It's a very big network, right?
Yes, sir.
All right. So
Class.
the second one slash 16, second one slash 16, which means that it has two. So you can see that these ones are multiples of 8. This slash,
Yeah.
they are always in multiples of 8. So there's no there's no doubt about you'll be able to easily calculate the number of hosts you can get and the number of
Network.
hosts that a network can contain.
Yes.
So it ranges from 128.0.0.0 to 191.255.255.255. Right? The default subnet mask is this. Yeah. So which means that how many hosts that can this one contain? That's 255 times 254. Abi?
Sir?
255. I said how many hosts that can this one contain? It's 255 times 254. That's the number of hosts. 255 times 254. Very, I see that you get it.
255 times what?
Times 254.
Why
Class.
4?
Okay, good question. The reason why it's not 255 is that when you establish your network, so one of the IP address will be for the network, right? And while the first IP address from the range will be for the network, the last IP address from the range will be for
The host.
broadcasting, not host,
Okay.
for broadcasting on the network. So in between the first and the last will be the ones that will be assigned to host. So if when we are calculating subnets, you will you will you definitely we will get there. You get so that's why it's 254 and not 255 because the last one is for broadcasting. So you definitely remove two IP address by default from the range of IP address you can get. One for the network and one for broadcast in the network. So yeah. And then we have class C, which is small network. It ranges from 192.0.0.0 to 223.255.255.255. And default subnet mask is this 3 octet occupied with the last one as the dedicated for host. So slash 24, like we said, is what is a number of ones that are on the subnet, right? And then we have so CIDR we've been explaining it. So It replaces the classful addressing to improve efficiency and reduce IP address exhaustion. It uses a variable length subnet mask. So this is it. So that slash something slash number is the it's what differentiates the classful from the classless, which is a it's what differentiates CID or the CIDR notation from the classful IP addressing. So yeah, notation X where X is the number of bits in the network portion. The number of bits in the network portion. We've explained this one. So then the real life example is this 10.0.0.0/8 represents a very large private network, while this one defines a small subnet for only 30 hosts. So why is it 30 hosts? Huh? You can see this one is 27, this one is 24, and this one is
I
25.
don't have idea.
Yes, check, look at this subnet now. Look at this notation 27. What does it mean? What does it mean? If you represent them in 1 1 1 1 1 1 1, so what does it mean? Hmm? Oh yeah, oh.
What did you ask? I not hear.
If you represent this one now, this question, this is what I asked. I said this IP address with this notation, cider notation /27. It defines a small subnet for 30 hosts. So it means that this network now can only contain 30 hosts. I was not asking why, so why is it 30 hosts?
Okay, I don't know.
You know,
Yeah, I don't know.
you should know now. Why is it 30 and not what's it called?
Because it is a small one.
It's a small one.
Yes, it is small, unlike the ones that are 255, 255.
So
This one is just 190.
asking is how did we get that 30? How did they come about this 30 that this thing can only contain 30 hosts? How come? So we'll get there, shall we get there? When we get to subnetting, when we get to subnetting, we'll get there, and then you better understand why is 30 and not even 32. Right. So our time is fast spent. So you can just familiarize yourself with the private and the other part of the note, right? So next class we'll continue from here. Familiarize yourself with the other part of IP addressing, which is the subnetting, uh, port and protocols. There's nothing much to actually talk about here anymore. So it's just like more like repetition of what we have explained before from the OSI model. And you can go and revise your TCP/IP OSI model as well to be able so that you'll be able to understand better. So the network diagram, I should add a um an image here, network diagram image, just to see allow us see how how it looks like. So that will be all for this class. Any question from this part, from what we have explained so far?
No question. No.
No question. Let no question. All right. So this will mark the end of our class this evening. Do have a pleasant evening. Thank you.
All right. Thank you, sir.